morning students and welcome to our YouTube channel Gnan Manjari Modern School. So in the previous video we have just completed the chapter number 5, that was powers and exponents. Okay students, in this video we will start with our new chapter, that is chapter number 6, algebraic expressions and identities. Okay students, algebraic expressions and identities. See here in the very first topic, that is algebra as generalization. See, this is all basic that you have seen in the previous standard. I am just revising you this all the things. So here I am just reading and we will see some of the examples of it. The most fruitful use of algebra is in generalization. When you say that the perimeter of a rectangle is equal to 2L plus B, or the area of a rectangular surface is L into B, well, L stands for length and rectangle and B for its breadth. We have a general formula which can be used for determine the perimeter and area of any rectangular surface. This generalization is true for any rectangle irrespective of numericals values of length and breadth. Look at the number series 1, 5, 9, 13, 17, 21. See here all the numbers 1, 5, 9, 13, 17 and 21. See here they are given. A 1 is equal to 4 into 1 minus 3, means 4 ones are 4 plus 1 minus 3. B is equal to 5, 4 into 2 minus 3, and 9 is equal to 4 into 3 minus 3. 13 is equal to 4 into 4 minus 3, 17 is equal to 4 into 5 minus 3, 21 is equal to 4 into 6 minus 3. So, all the things we get the answer, that is 1, 5, 9, 13, 17 and 21. In general, the formula is 4x minus 3. See here the numbers, the given numbers are 1, 5, 9, 11, 1, 5, 9, 13, 1, 5, 9, 13, 17 and 21 are given. Okay students, so in that let us see one by one how they just make the formula. See here 1 is there, then 1 is equal to 4 into 3 minus 1, 4 into 1 minus 3. Okay students, and the next is 5, that is 4 into 2 minus 3, and the next is 9, that is 4 into 3 minus 3. The next is 17, that is 4 into 5 minus 3, and the next is, before I that forgot about the 13, so that I am writing that over here, 13, that is 4 into 4 minus 3, and the next one is 21, that is 4 into 4 into 6 minus 3. Okay students, so from this 4 ones are 4 minus 3, 1, 4 twos are 8, 8 minus 3, 5, 4 threes are 12, 12 minus 3, 9, 4 fives are 20, 20 minus 3 is 17, 4 fours are 16, 16 minus 3, 13, 4 six are 24, 24 minus 3, 21. Okay, from this we can say that if we can make a formula, which formula? 4x minus 3, 4x minus 3. See here where x, what is x? These numbers, if I take 1 over here, then we get 1, 2, then this 3, then this 4 then this, 5 then this, 6 then this. Okay students, so this is given. Moving further, in careful observation we will give us the general formula for the term 4 as 4x minus 3. Once you get the general formula, we can find any in the term number series. For example, 7th term. What will be the 7th term? So 4 into x minus 3. We have to put here in the place of x 7. So 4 7s are 28 minus 3, that is 25. 10th term, so 4 into 10 minus 3, 40 minus 3, that is 37. 100th term, 4 into 100, that is 400 minus 3, that is 397. Look at the pattern of the squares made with the matchstick given in the figure 6.1. See here, a figure is given in the matchstick. You can see that number of the square 1, 2, 3, 4, 5 and n. So here in the one square, in the square number 1 there are 4 sticks. See here, at the bottom it is written number of matchsticks. In the second, how much sticks required? Only 7. In third, only 10. 4 only 13. 5 only 16. And n, then 3n plus 1. We have made a formula for that. See here, for example, number 1, there are given, let the numbers of triangle be x and the numbers of matchstick be y. See here, triangle is equal to x. In 1 there are 3, 2, 6, 3, 9, 4, what? And we have to make a formula over here. You can see that. So for that, if the first is given is example number 1, talking about example number 1. In first triangle there are 3 sticks. In the second triangle, 2 triangle, 6 matchsticks. In the third 3 triangles, 9. 3 3s are 9. Means I can say that y is equal to what? X is equal to triangles and y is equal to matchsticks. Matches. Okay students, so for that I can say that y is equal to 3x, y is equal to 3x. See here, we get this formula. How? Y is equal to 3x. If I want a triangle 1, then how many stick needed? So x is equal to 1, then stick is needed 3 ones are 3. If I need 2 triangles, that is x is equal to 2, 3 2s are 6, y is equal to 6, means matches is equal to 6. If I want to make 3 triangles, then 3 3s are 9. How many matchsticks? 9 matchsticks. Okay students, in that way there is an example number 2. Let the numbers of the post be x and the numbers of railing between the post be y. Okay students, you can see here, let the posts be x, posts be x and the number of railing between the posts be y. See here students, it is given that post is x and y are given in this. Here there is some change. In previous example number 1, that was triangles and matchstick. Now what? So x is equal to posts and y is equal to railings. Y is equal to railings. Okay students, here you can see here 1 posts, 0 railings. See here, it is given. In the second 4, see 4, and in the third it is 8, in the 4 it is 12. You can say that it is the table 4 1s are 4, 4 2s are 8, 4 3s are 12. You can see that. But how we will write this? We will write this as y is equal to 4x minus 1. Okay students, 4x minus 1. See here, if I want posts 1, then 1 minus 1, 0. 4 into 0, 0. You can see in the table the value of y is equal to 0 when x is equal to 1 second. 2 posts, then x is equal to 2. 2 minus 1, 1. 4 ones are 4. Okay students, so y is equal to 4. When x is equal to 2, then y is equal to 4. Then taking x is equal to 3. Okay students, x is equal to 3. 3 minus 1, 2. 4 2s are 8. Okay students, y is equal to 8. When we take x post is equal to 3, then we get reeling is equal to 8. Okay students, in that way they have calculated the example number 2. You can see that the above answer 3x, see a note is given, 3x and 4x minus 4 are both algebraic expressions. Now let us study algebraic expressions in more detail. See here, the exercise 6a, that is basic exercise, you can do it by your own. Okay students, now moving towards next. So our next topic is, that is term of an algebraic expressions. Okay students, let us see that. So more about algebraic expressions. First of all, I am just reading the theory. Okay students, you can see that the expressions has both variables represents x, y, z, etc. and constants represented by the numbers such as 3, 4, minus 5. We all know that what are variables means the letters x, y, z and any of the letters a, b, c also can be there, any of the letters can be there. And what are constants? The constants are the numbers 3, 4, minus 5, etc. All the numbers can be possible. An algebraic expression thus is a combination of numbers, literals and arithmetic operations. In algebraic expressions, the numbers are connected together with operations of addition or subtraction. In an algebraic expressions, there may be many terms. Each term is either a constant like 8, minus 5, 56, etc. or a variable x, y, etc. or the product of the constant with the variables. Here it is also written as 4x, minus 34y, etc. or the product of different variables like a, b, c, minus x cube y square, 76 a cube b square c, etc. Look at the algebraic expression 7p square q plus 3pq minus 50. There are the three terms in the expression 7p square q, 3pq and minus 50. Each of the following term can be factorized to form the factor which cannot be further factorized. See here, it is first example is given that 7p square q, then 7 into p into q, we can write that, and another is 3pq. In that 3 into p into q, if it is given 6pq, then 3 into 2 into p into q. When we find the factors of a number term, the constant is taken as one factor even if the constant is a composite number having factors of its own. The factorization of the number terms of an expression can be easily expressed by a tree diagram. Following is the tree diagram for the above expressions. See here, you can see a factorization tree diagram. Okay students, types of algebraic expressions. Now we will see the types of algebraic expressions. See here, all the theory, I know that this theory is to be only read it. Okay students, see here, just I am reading, and when the example will come, I will explain it. Okay students, types of algebraic expressions. If there is only one term in an expression, it is called a monomial. Thus the expressions 5x is a monomial as it has only one term, means the algebraic expression monomial, then binomial and trinomial. Means monomials means only 4x, only one only one term is in the expression, then it is known as monomial, and binomial means it has 2 and trinomial means it has 3. See here I am just reading 2x plus 3 has 2 different terms, so it is called a binomial. 3a plus 4b plus c is a trinomial as it has 3 different terms. All these expressions are also referred to as polynomials. In a polynomials there can be any numbers of term, but none of the terms can have a negative exponents for any variable in the denominator. 3x, 3 by x, 3 by x square, or 3x raised to minus 1, 3x raised to minus 2. It is not polynomial. 3x square plus 5x plus 3 is a polynomial, while 3x square plus 5 by x plus 3 or 3x square plus 5x minus 1 plus 3 is not a polynomial. However, an expression of the type x square upon 3 plus x by 5 plus 3 would be a polynomial as there is no variable in the denominator. Thus, all polynomials are algebraic expressions, but all algebraic expressions are not polynomials. See here an example is given, example number 3. I think of a number x, add 5 to it and divide the result by 3. Write the statement as an algebraic expression. So, there is an example given, that is example number 3. In that they have tell that, see here, think a number of x. We have to just think a number of x. See here, this is a number of x. Okay students, this is x, and the other number, add 5 to it and divide the result by 3, means there is a number x. In that we have, what we have to do, we have to add 5 and further then it is divided by 3. So, this is that number. Okay students, this is that number. In the x place, if there is value is given, then you can put the value. If there is x is equal to 1, then 1 plus 5, that is 6. 6 by 3, that is we will get the answer 2. And now that only there is another example. See here, example number 4. I think a number of x. Okay students, see here another example, example number 4 that I am writing. See here, example number 4. See here, first what is given? I think of a number x. So, there is a number x. Yes, there is a number x, and add 7 means we have to add 7. So, we have added x plus 7. We have added 7 and then multiply the result by 3. Then we have to multiply this by 3. So, what we will do, 3x plus 7. Okay students, 3x plus 7. This is the A. Now, moving towards B. B is, I think, a number of y. See here, B is given a number that is y, and what? Multiply it by 9. We have to multiply that number by 9, 9y. Okay, we have multiplied that and then subtract from 10. So, we have to subtract 10. So, 9y minus 10. Okay students, if you will do step by step process, then your answer will never be incorrect. Okay students, in that way, see here, there are examples are given in exercise 6b that you can do easily. See here, in that list the factor of each term of the expressions given below. Okay students, in that, first question, that is from each of the given algebraic expression, list the term with variable and term with only constants. Okay students, in that we have to just first of all separate out the variables and the constants, and in question number 2, list the factors of each of the following. Means factors means 5a is given, then 5 into a, that are factors. C, b, a, b and c are given, then a into b into c. This thing you have to do in question number 2, and In question number 3, fill in the blanks with words from the list. Monomials, binomials, trinomials, polynomials, algebraic expressions and 2. See here that you know these are some of the definition which are given here. And question number 4, classify the following expressions as monomial, binomial and trinomial. See here, a 5x, that is monomial. If two terms are there, that is C here, C in the C 2x plus y, that is two terms are there, so it is binomial. If three terms like D 3x square plus 5x y and y square, that has three terms, so it is trinomial. So you have to just separate out the binomials, monomials and trinomials. Okay students, and now moving towards next, that is simplification of algebraic expression. What is it? Let us see that students. So our next topic is simplification of algebraic expressions. We see here the three terms are given: constants, coefficients and power. So first of all, what is constants? So if I take a term, see here, I have taken 3x square over here. So what is first of all here? 3x square plus 3. Here first of all, what is constant, what is coefficient and what is power? Okay students, we will see that. So for that, see here, what is coefficient? Numerical coefficient over here. So the coefficient, that is, I can say that this is coefficient. Coefficient. Okay students, that is coefficient. Another, what is the power? What is power? See here, this is the power. And at last, that is constant. What is constants? So this is constants. Okay students, this is constant. See here, we have just seen, if I take 3x square plus 3, then what is coefficient? This 3 is coefficient. What is power? The raise, x raised to anything is the power. And what is constant? That is 3, which is have no variables. Okay students, next, here first of all, reading the theory part, take the examples of monomials like 3x, 5x square, 8ab cube and so on. See here, 3 in 3x, 3 is the numerical coefficient and the power of x is 1. In 5x square, 5 is the numerical coefficient and the power is 2, and x square is a literal factor. In 8ab cube, 8 is a numerical coefficient, the power of a is 1 and the power of b is 3. ab cube is a literal factor. As we have already seen, the terms which do not have variables multiplied to them are called constant. Means these are the constants. A constant is an independent of the variables to consider the above in the expressions. Here you can see that an expression is given, that is 7ax cube plus 9b square y minus 8z plus 5. Here 5 is the constant. See here, plus 5 which has no variable, it is constant. 7, 9 and minus 8 are numerical coefficient of ax cube, b square y and z respectively. 3 is the power of x, 2 is the power of b, and 7ax cube, 9b square y minus 8z y, all are the expressions, and there are 4 terms in these expressions. Okay students, Next, like terms and unlike terms. So what is like term and what is unlike term? So in that, what is like term? What is like term? So like term means the variables are same. That is, if I take 2y, y, only y raised to 3 or y raised to 2. So here the y is same, so that are like term. And the unlike term, what is unlike term? Now you say that. So what is unlike term, students? See here, sorry students, this x cube and x square are not. So they, now I can say 3x, 4y, 5y, then these all are the like terms. Okay students, but if I take 2xy, 3yx or 4xy, so these are also the like terms, but the unlike terms, these both are like terms. And the unlike term means 2y square, 4y cube, these are unlike term. Okay students, these are unlike term. Let us see some of the examples of it. See a like term and unlike term. Observe that all the three terms mentioned in each of the following listed have the same variable part in them. X, 5x and 8x are called like term. 5xy, 3xy, 8xy are also like term. 3x square y, 9x square y and x square y are also like term. And here you can see the variables which are same are like terms, and the variables which are different are not like terms. See which are unlike terms, that is x and x square are unlike term, 5x and 4xy are unlike terms, x square y and x y square are also unlike term. Okay students, so in the further we will see in the next video. Your today's homework is in the page number 82, try this, that is your homework, and exercise 6a and 6b is your homework. So your today's homework is, students, your homework is exercise 6a and 6b. Okay students, if you have any doubt you can just message me, don't call students, I will not answer your call. If you have any doubt you can say me that, sir, we have doubt in exercise 6a question number 1 in that a, b or c. But if you will call, I will not answer your call. You have to compulsory do the message that I have doubt over here. Okay students, and on the page number 82, try this. That you have to do in your homework. So this is your homework. Okay students, up till then stay safe, stay home. Okay, bye students. you.